So we are going to take the question, obtain the expression for potential energy of a dipole in an external field. लिखो P of a dipole, मतलब शॉर्ट में लिखेंगे potential energy of a dipole in external electric field. Potential energy of a dipole. We have already seen dipole. Dipole हमने already देखा है. देखो यहाँ पे फिगर है. Dipole consists of two equal. यहाँ पे मैंने वापस रिवाइज किया है. Two equal and opposite charges. Minus q plus q. O is the center. 2L. Short revision. 2L is the distance between the charges. And dipole moment P bar is q into 2L bar, directed from negative charge to the positive charge. ये dipole moment है. ये हमने सब देखा है. Dipole moment, length of the dipole. We have seen these things. Okay, and then we have seen that already हमने देखा है torque acting on the dipole. ये potential energy of the dipole है. But we have already seen torque acting on the dipole in external field. यहाँ पे देखो torque acting, obtain expression for torque or couple acting on a dipole. तो क्या किया था हमने? We kept the dipole in external electric field. ये E bar है. External electric field E bar plus Q minus Q charge याद है? Plus Q E bar minus Q E bar. It creates a torque. These two create a torque. ये torque create करते हैं and torque का formula भी हमने निकाला था. The formula was torque is equal to P sin theta. Torque is equal to P sin theta. Okay. And in terms of vector product, it is P bar cross E bar. Okay. So torque acts on the dipole. इसका formula हमने already derive किया है in external electric field. So this is external electric field in which dipole is placed. ये plus q, ये minus q. Okay, and force acts on this plus q bar. And if this is minus q, force acts on it minus q bar, and therefore torque acts. And what is the magnitude of the torque? Pe sin theta, where theta is this angle. ये हमने already देखा है. Okay, torque is Pe sin theta. This we have seen, and it is a vector quantity P bar cross E bar. Is that clear? And now what we are going to see, potential energy of a dipole in electric field. Potential energy of a dipole in electric field. So this is the question. Potential energy of the dipole in electric field. ये torque का था. Torque acting on a dipole in external electric field. Now potential energy of a dipole in external electric field. And I have written here that this part is taken, so don't use this basically ये वाला मत यूज करो, you can scratch this, obtain the expression, ये वाला scratch करो, बिल्कुल एंड में मैंने I have taken the theory again because I wanted to take something extra also, okay, which is not there in those notes. So ये क्या है? Potential energy of dipole in uniform electric field, in uniform electric field, okay. So क्या क्या लिखा है? Consider an electric dipole of moment p bar. तो हमने ऑलरेडी p bar तो किए है, ओके. तो consider an electric dipole of moment p bar placed in uniform electric field e bar, placed in uniform electric field e bar. Here plus q charge, here minus q charge. So q e bar is the force, minus q e bar. I have written minus q e bar, मतलब leftward. Okay, and dipole moment makes an angle theta. Only they have written length of the dipole as 2a. मैंने दूसरा बुक यूज किया है, instead we write 2a, but इसका कोई फर्क नहीं पड़ने वाला है. Torque acting on the dipole is given by p sin theta. Okay, so start writing. Figure draw करो. So torque already p sin theta add हो रहा है. So draw the figure and write. Torque acting on the dipole is p sin theta. P sin theta. Theta. P sin theta. Now what we want to do is see potential energy find out करनी है, okay. But before that हमको एक क्वेश्चन ऐसे सॉल्व करना है, एक क्वेश्चन ऐसे सॉल्व करना है कि सपोज इनिशियली ये थीटा 1 एंगल पे, सपोज इनिशियली एट एंगल थीटा 1, ओके, थीटा 1, एंड आई वांट टू रोटेट दिस like this from angle theta 1. I want to rotate this to theta 2, and if you see very carefully, try to remember torque is p sin theta. So when theta was 0, torque was equal to 0. That means theta was 0, torque was equal to 0. That means dipole was parallel, okay. It is called an equilibrium, dipole equilibrium में था, okay. Dipole was in equilibrium. So now if I want to move the torque like, sorry, I want to move the dipole like this, I want to rotate the dipole like this. This is very important. अभी पहले थीटा 1 में टॉर्क कब मिनिमम था? When theta was 0, okay. Right now थीटा पे, but if I want to rotate it like this, ऐसे है, तो क्या करना पड़ेगा? See, स्टेबल पोजीशन इसकी ये है, पैरेलल. मैं उसके अगेंस्ट रोटेट कर रहा हूँ, अगेंस्ट. That means I have to apply the external torque. So I am going to rotate it from theta 1 to theta 2. Okay. So torque is equal to p sin theta. I have written. Okay. We want to rotate dipole. लिखते जाओ. From theta 1 to theta 2, and ये क्लियरली जो तुम्हारा ये टॉर्क है ना, इलेक्ट्रिक फील्ड का टॉर्क है ना, इलेक्ट्रिक फील्ड का टॉर्क ऐसे रोटेट करने की कोशिश करेगा, मतलब क्लॉकवाइज, एंड आई एम ट्राइंग टू रोटेट इट एंटी क्लॉकवाइज. सो ये इलेक्ट्रिक फील्ड के अपोजिट है, ओके. रोटेट डायपोल फ्रॉम थीटा 1 टू थीटा 2 opposite to torque of ई बार का जो टॉर्क है क्लॉकवाइज है, ई बार का टॉर्क क्लॉकवाइज है, एंड आई वांट टू रोटेट इट एंटी क्लॉकवाइज. ओके, यू कैन राइट ई बार टॉर्क इज क्लॉकवाइज एंड आई वांट टू रोटेट इट एंटी क्लॉकवाइज. मुझे उल्टा रोटेट करना है, तो आई हैव टू अप्लाई द एक्सटर्नल टॉर्क. Okay, therefore tau external is to be applied. क्योंकि जो torque of electric field है, it will try to rotate the dipole like this and it will finally bring the dipole parallel to the field. मुझे उसके उल्टा रोटेट करना है, theta 1 to theta 2. So torque apply करना है. Okay, and we know that work is equal to force into displacement. वैसे हमने क्या है टॉर्क में, रोटेशनल मोशन में क्या पढ़ा है? टॉर्क इज इक्वल टू व्हाट? फोर्स के जगह सॉरी वर्क इज इक्वल टू इन रोटेशनल मोशन वर्क इज इक्वल टू क्या आएगा? टाउ थीटा. सो यू विल फील दैट अभी मुझे जो वर्क है सो वर्क हैज टू बी डन. टॉर्क अप्लाई करना है एंड आई वांट टू चेंज द थीटा. सो ये एंगुलर डिस्प्लेसमेंट हो गया. So in rotational motion work is torque into angular displacement. ये तो हमने देखा है angular displacement. So you feel that work is equal to torque into theta 2 minus theta 1. This is the work. But the thing is, this is not done because why? Why not done? ये क्यों नहीं होगा? क्योंकि this will be the formula when torque is constant. अरे यार यहाँ पे क्या हो रहा है? As you are changing the theta. जैसे तुम थीटा चेंज कर रहे हो, P is constant, dichromacy is constant, E is constant. When you are changing the theta, sin theta is changing. So when you are rotating the dipole, torque is changing. Torque change हो रहा है. जैसे W is equal to Fs में F change हो रहा है, तो it is a question of variable force. तो हम लोग कैसे निकालते हैं? Work is equal to integration dW. It is integration FdS. Force अगर constant नहीं है तो similarly torque is not constant. So directly you cannot find out. This is a question of variable torque. Question of variable torque. So कैसे find out करोगे? You must use पहले क्या करना पड़ेगा? Small angular displacement लेना पड़ेगा. So what is written? If the dipole is rotated through a very small angle d theta against this torque, मतलब इस clockwise torque के against rotate किया, then small amount of work done is write down. If the dipole is rotated through a very small angle d theta, because there is a variable torque, has to be solved by calculus. If the dipole is rotated through a very small angle d theta against this torque, through a very small angle d theta against this torque, then work done is dW is equal to tau d theta. And what is the torque? PE sin theta d theta. So small amount of work done for infinitesimal angular displacement d theta. Work done. Okay, तो मुझे थीटा 1 से थीटा 2 जाना है, तो फर्स्ट आई गिव वेरी स्मॉल एंगुलर डिस्प्लेसमेंट इनफाइनाइटेसिमल. ओके, जिसके लिमिट्स है थीटा 1 टू थीटा 2. तो पहले dw निकालो, p sin theta. So write down therefore total work done in rotating the dipole from theta 1 to theta 2. Therefore total work done in rotating the dipole from theta 1 to theta 2, W is equal to integration theta 1 to theta 2 क्या है? P sin theta d theta. लिखते जाओ. Go on writing. Total work done in rotating dipole from theta 1 to theta 2. Okay, P and D constant. You can write down. P and D are constant. They can be taken outside the integral. So what remains inside? Theta 1 to theta 2 sin theta d theta. As p and e are constant, they can be taken out of the integral, and therefore work is equal to p. What is the integral of sin theta? Minus cos theta from theta 1 to theta 2. Theta 1 to theta 2. Take this minus outside. So मैंने minus outside लिया. So inside है cos theta. Go on writing theta 1 to theta 2. Okay, and therefore total work done is equal to minus p, put the upper limit, cos theta 2 minus cos theta 1. This is the work done in rotating the dipole from theta 1 to theta 2 against the torque of E bar. Against the torque of E bar. This is the work done. Okay, I hope it is done. Now see, initially इसके स्पेशल केसेस हो सकते हैं. Suppose the initially dipole जो है it is at right angles to the electric field. मतलब initially dipole right angle पे. Okay, so let us suppose that, लिखते जाओ. Let us suppose that dipole is initially at right angles to the electric field. मतलब initially right angle से इसका मतलब theta 1 जो है वो 90 है. theta 1 is 90. Initially 90 degrees पे मतलब theta 1 90 है, 90, and ये ऐसे theta तक आ रहा है. मतलब initially dipole was perpendicular, मतलब theta 190 था, and now it is brought to the angle theta. theta इसके साथ है, इलेक्ट्रिक फील्ड के साथ theta है, इलेक्ट्रिक फील्ड के साथ. मतलब यहाँ से theta नहीं घुमाया. Remember, very important, theta 2 जो है that angle is also with electric field, और theta 1 जो है वो, तो अदरवाइज यू विल गेट कंफ्यूज्ड कि पहले 90 पे था और फिर यहां से थीटा घुमाया. नो, पहले 90 पे था और फिर यहां से थीटा घुमाया. नो, यहां से फ्रॉम हियर इट इज रोटेटेड बाय 90 माइनस थीटा, क्योंकि ये टोटल 90 है, तो इलेक्ट्रिक फील्ड के साथ थीटा हो जाएगा. सो थीटा इज द एंगल विद इलेक्ट्रिक फील्ड. सो डोंट गेट कंफ्यूज्ड कि पहले 90 पे था, मतलब थीटा 1 90 था, तो थीटा 2 किसके साथ एंगल है? थीटा 2 भी इलेक्ट्रिक फील्ड के साथ एंगल है. थीटा 2 इज आल्सो एंगल. सो थीटा 1 इज 90 and theta 2 is theta. It is with this. You can draw this figure. Very important. So from 90 degrees theta नहीं घुमाया ऐसे. From 90 degrees घुमाया 90 minus theta, so that with electric field it is theta. So let us suppose that should be absolutely clear. ये बहुत important है. Initially at right angles and then brought to a position making an angle theta with the direction of electric field. लिखो अच्छे से. तो क्या होगा? तो work done is equal to minus p cos of final angle theta है and initial cos of 90. Cos 90 0 है, तो work is equal to minus p cos theta. Work done is equal to minus p cos theta. So initially angle was 90 degrees and it is brought like this and it is made at angle theta. Now you will have confusion in mind कि when we started I said कि ये थीटा पे था, इट वाज रोटेटेड अगेंस्ट द टॉर्क ऑफ दिस, अगेंस्ट, ये कंफ्यूजन होगा कि हमने तो अगेंस्ट घुमाया है, ओके, अगेंस्ट घुमाया, वी हैव रोटेटेड अगेंस्ट, ओके, अगेंस्ट, तो why we are saying like कि ये first it is perpendicular, तो अभी हमको तो it is going in the direction, so you don't have to apply the external torque, okay, you don't have to apply the external torque because ये तो अपने आप ही जाएगा ना, because if the dipole is pi, ये तो ये act होगा q bar and here minus q bar, so it is going to rotate automatically, you don't have to apply external torque against this torque of electric field, okay, ये confusion होगा. Now listen very carefully, that's why the answer has come negative, क्योंकि theta acute है तो cos theta will be positive, p is positive, now work is done by the electric field, तो तुमने external लगाया ही नहीं, that is why answer is coming negative. Remember, if I would have applied the torque, the work done would have been positive. कैसे positive आया? For example, if I would have rotated it from 30 to 60, मतलब यहाँ पे पहले 30 पे था and 60 पे घुमाया, ओके, तो कितना? 30 to 60, तो वर्क कितना आएगा? Work is equal to minus P E cos of theta, मतलब cos of 60 minus cos of 30. So I rotated from theta 30 to 60. So I rotated from 30 to 60. Now suppose P का वैल्यू कुछ तो हम लोग लेते हैं 2, E का वैल्यू 10. How much is cos 60 root 3 by 2? Okay, it is around 0.86. Root 3 by 2 is 0.86. Cos 60 is half. Cos 60 is half, 0.5. Cos 60 is half, and cos 30 root 3 by 2, cos 60 1 by 2, cos 30 root 3 by 2, 0.86. क्या है आंसर? -20 into ये 0.80 ले लो टाइम पास में, 0.5 minus 0.8 minus 0.3. So आंसर कितना है? 6 जूल. Work is 6 जूल. Is the answer. Positive क्यों आया? Because you rotated it from 30 to 60. That is against the direction of field. तो तुम्हारा आंसर पॉजिटिव आया. Against the direction मतलब against the torque of the field, not direction of the field. Against the torque of the field. Okay, properly speaking, against the torque of the field किया, तो तुमने external torque लगाया, so work has come positive. Work has become positive. ओके, नाउ 92 ऐसे गया, तो 92 थीटा पे गया, सपोज पहले 90 पे था, फर्स्ट इट वाज एट 90, तो वर्क नेगेटिव आएगा, देखो क्यों? माइनस ये 2, ये 10, ओके, एंड फर्स्ट इट वाज एट 90 एंड इट वाज ब्रॉट टू से 60, इट वाज ब्रॉट टू 60, 90 टू 60, पहले 90 पे था एंड इट केम टू 60 डिग्रीज विद द फील्ड, 90 पे था 60 पे, तो यहाँ पे क्या आएगा? cos 60 थीटा टू 60 है ना, थीटा टू 60, थीटा और 90, यही फॉर्मूला है, तो cos 61 by 2. नाउ वर्क कितना है? -3. क्यों? बिकॉज इट इज रोटेटिंग इन द डायरेक्शन ऑफ टॉर्क ऑफ E bar, इन द डायरेक्शन ऑफ टॉर्क ऑफ E bar. सो यू डोंट हैव टू डू एनीथिंग, तो वर्क नेगेटिव आएगा. ओके, वर्क इज नेगेटिव. So that you have to remember कि ऐसा क्यों है, क्या है. Okay, so I hope you have understood this. Okay. Now, so work is minus P sin theta when initially dipole was perpendicular to the field and it was taken to angle theta. Dipole theta angle पे with the field लेके, तो work done is minus P cos theta. Okay, this work done is stored, लिखते जाओ, this work done is stored in the dipole in the form of potential energy. This work done is stored in the dipole. This work done is stored in the dipole this work done is stored in the dipole in the form of potential energy U. This work done is stored in the dipole in the form of potential energy U. Therefore, potential energy of the dipole is given by minus P cos theta. Minus P cos theta. Okay? Minus P cos theta. Potential energy of the dipole is given by U is equal to minus P cos theta. And in vector form, P and A are vectors and cos theta potential energy is scalar, so minus P bar dot E bar. This is the potential energy of the dipole in external electric field. External electric field. Clearly, potential energy scalar है तो हमको पता है, it is measured in joules. And now see, this is very important. This is very important. Okay. Now to take, see, अगर मैंने ऐसे किया होता, to define the potential energy. Listen very carefully. To define the potential energy. Okay, मैं ऐसा भी कर सकता था कि like I would have done like this कि initially dipole is parallel to the field and then it is rotated by angle theta. तो work done कितना आता? Listen very carefully what I am talking. Initially parallel मतलब theta 1 तुम्हारा 0 है. जो हमने 90 लिया था ना, theta 1 was 90. Theta 1 was 90. Now I take it theta 1 0, तो मैंने 90 से थीटा नहीं लाया, I am taking from 0 to theta, so theta 2 is equal to theta. So work done कितना होगा? Work done will be minus P cos theta 2, मतलब cos theta minus cos 0 और cos 0 जो है वो 1 है. So work done would have been minus P into cos theta minus 1. So work done is equal to, if I put minus inside, it would have been PE into 1 minus cos theta. So I should have chosen work done to rotate from 0 to theta. But to define the potential energy, I have chosen to rotate it from perpendicular, that is 90 to theta. तो अभी potential energy ये है या पोटेंशियल एनर्जी ये है, क्योंकि दोनों तो फॉर्मूला अलग अलग है. एक है माइनस पी कॉस थीटा एंड द सेकंड वन इज पी इनटू 1 माइनस कॉस थीटा. सो व्हिच वन इज द करेक्ट फॉर्मूला फॉर पोटेंशियल एनर्जी? रोटेशन फ्रॉम 0 टू थीटा और 90 टू थीटा. ओके, द आंसर लाइज ओवर हियर. इट इज customary to choose a potential energy of the dipole to be 0. See, potential energy, if you remember, potential energy इतना बड़ा है potential energy के बारे में, vertical circular motion से लेके WP, potential energy is always measured with reference. तो एक टेबल है, टेबल. मैंने if I take here 0 joule top of the table, I can call this bottom minus 10 joule. टॉप से प्लस 20 जूल. इट्स कंप्लीटली रेफरेंस बेस्ड. हमने देखा है इंफिनिटी पे 0 लेते हैं, सब हमने देखा है पोटेंशियल के बारे में, पोटेंशियल एनर्जी के बारे में. इफ आई टेक दिस एज 0, तो ये 20 था तो ये हो जाएगा -20, ये हो जाएगा -30, लाइक दैट. सो इट कंप्लीटली डिपेंड्स अपॉन द रेफरेंस. सो टू डिफाइन द पोटेंशियल एनर्जी, इट इज नेसेसरी टू सिलेक्ट द रेफरेंस. तो मैंने 0 का रेफरेंस सिलेक्ट किया, 0 से थीटा, from 0 to theta. If I select 0 as a reference, then this will be the potential energy. If I select 90 as a reference, initially at 90 to theta, this is the potential energy. Okay. Now, for specifically dipoles in electric field और magnetic field में भी वही देखेंगे हम लोग. Okay, magnetic dipole in magnetic field, magnetic dipole in magnetic field जब करेंगे, या इलेक्ट्रिक डायपोल इन इलेक्ट्रिक फील्ड, पोटेंशियल एनर्जी ऑफ द डायपोल 0 लेते हैं व्हेन द डायपोल इज परपेंडिकुलर टू द फील्ड. when the dipole is perpendicular to the field. Okay, dipole is perpendicular to the field. ये convention है, convention. So you have to remember, this is not the answer. 0 to theta घुमाया तो work done is not the answer for potential energy. 90 to theta लेंगे, that is the answer for potential energy. It is customary to choose potential energy of dipole to be 0 when the dipole is perpendicular to the electric field. In any situation involving potential energy, we are free to define zero potential level. अभी तो मैंने दिखाया zero potential level you can define in arbitrary manner. Okay, because absolute potential energy does not have meaning, rather difference is the meaning. Difference 30 का है, difference 30 का है. I can call this as 0, this as 30, or this as 0, this as minus 30. So potential energy absolute does not matter, change matters. तो absolute के लिए 90 का reference 0. So when theta is 90, वहाँ से theta तक लिखा है. Okay, so this is very important. So this is the formula for potential energy of a dipole. Okay, so write down. So I have explained you. This is not the formula. This is the formula for work done. ये work done definitely है. Work done when the dipole is rotated from 0 to theta. This is the formula for work done when the dipole rotates from 90 to theta. But that is also the formula for potential energy of the dipole at an angle theta. This is not the formula for potential energy. So write down now special cases. Special cases. When theta is equal to 0. Special cases लिखो. First, theta equal to 0 है. Theta equal to 0 है तो cos theta will be 1. तो u is equal to minus p. Theta equal to 0 means क्या? The dipole is in the direction of the field. मतलब dipole ऐसे है, plus q इस साइड में and minus q इस साइड में, minus p इस साइड में. So potential energy उसका minus p. अगर तुमको याद होगा तो vertical circular motion में if this is r, if I define center at 0, then ये वाला जो होगा, अगर ये r होगा, then this will be minus mgr, minus mgr. और यहाँ का पोटेंशियल एनर्जी प्लस mgr. ये बीच वाला कर देते, वैसे 90 डिग्री जो है ना, 90 डिग्री, यहाँ पे पोटेंशियल एनर्जी का 0 आएगा देखो. ओके, 90 डिग्री. सी when theta is equal to 90 degrees, cos theta 0 आएगा and potential energy u कितने आएगी? Potential energy will be 0. So when dipole is perpendicular to the field, electric field, potential energy is 0. तो ये 0 ऐसे. When theta is 90 and when theta becomes 0, ये plus q here, minus q here, potential energy minimum है and that is minus p. I hope you understood. In this position, the dipole has minimum potential energy, and we know that minimum potential energy is a stable equilibrium. So write down. Hence it is a stable equilibrium. Okay, ये minimum है. The dipole has more potential energy in all other positions. So you can understand यहाँ से कि ये 90 डिग्री वाला केस है, मतलब परपेंडिकुलर वाला. This is stable equilibrium when plus q and minus q, plus q is on this side and minus q on this side, like this. तो minus mgr है वैसे minus p, यहाँ पे 0 है like that 0. लिखो वहाँ से अच्छे से. And third case, ये plus q यहाँ उल्टा, minus q is over here. Okay, in that case theta कितना होगा? 180 degrees. Theta 180 degrees and cos theta will be minus 1. And cos theta minus 1 then work, rather potential energy, not work, potential energy will be, if this is -1, potential energy will be plus P, and which is maximum. In this position, dipole has maximum potential energy, therefore it is unstable equilibrium, definitely unstable है. Okay, even if you displace it slightly, वो rotate होके stable equilibrium में जाएगा. Stable equilibrium मतलब I have kept, by some means I have kept in unstable equilibrium and slightly displace it. खटाक से घूम के हो, it will go to the stable equilibrium position. So write all this and all this. I hope this is clear to you. Okay, so note the potential energy of the dipole is minimum when P bar and E bar are in same direction. That is obvious. Plus Q this side, minus Q this side. P bar is directed from minus Q to plus Q. So theta 0. So potential energy is minimum when P bar and E bar are in same direction, and maximum जब ये plus Q और minus Q होगा तो P bar E bar के opposite direction में होगा, मतलब 180 degree. So that is obvious. Okay, and now the next you can write down, ये तो potential energy देखा, and now work done in rotating dipole in uniform electric field. Work done in rotating the dipole. वैसे तो हमने फार्मूला निकाला यही था ना, वर्क डन का फार्मूला है ऑलरेडी डन. W is equal to minus P into what? Cos of theta 2 minus cos of theta 1. This formula we have already done. Work done to rotate the dipole in electric. Right side, work done in rotating the dipole in uniform electric field. Okay, now let us see what we are saying. Suppose an electric dipole is rotated in uniform electric field through an angle theta from stable equilibrium position as shown. Okay, stable equilibrium मतलब stable equilibrium में था, stable equilibrium and it is rotated like this. ऐसे rotate किया theta. तो potential energy of the dipole, this is very important. Potential energy of the dipole is minus P cos theta. So even if you rotate, this is very important. What they are saying, electric dipole is rotated through an angle theta. So you rotated this from stable equilibrium position to theta, तो भी उसका potential energy is not the work done from stable to here. Okay, potential energy is always defined work done from 90 degrees to theta. So even if you displace it from stable to theta, potential energy is always defined from this position. So potential energy is minus P cos theta. Okay, so this you have to remember very carefully. Never define the potential energy from stable to theta. It is from 90 to theta. 90 to theta. Okay, so write down. At angle theta, पोटेंशियल एनर्जी ऑफ डायपोल U कितना होता है माइनस पी कॉस थीटा ओके एंड राइट डाउन व्हेन द डायपोल इज इन या तो ये लिखना जरूरी नहीं है यहां से लिखेंगे व्हेन द डायपोल इज इन स्टेबल इक्विलिब्रियम पोजीशन व्हेन द डायपोल यहां से लिखो दैट इज बेटर व्हेन द डायपोल इज इन बट दिस इज वेरी इंपॉर्टेंट हम लोग रोटेट कर रहे हैं वी आर रोटेटिंग इट फ्रॉम 0 to theta but at this point potential energy is defined from 90 to theta तो potential energy का फार्मूला यूज कर रहे हैं so when the dipole is in stable equilibrium position पहले लिखो वहां से लिखो right from there when the dipole is in stable equilibrium position that is theta equal to 0 initial potential energy is equal to माइनस पी कॉस 0 तो ये तो पहले हमने देखा है माइनस पी एट थीटा इज इक्वल टू 0 व्हेन द डायपोल इज इन स्टेबल इक्विलिब्रियम पोजीशन दैट इज थीटा इक्वल टू 0 इट्स पोटेंशियल एनर्जी इज माइनस पी ओके नाउ व्हेन द डायपोल इज रोटेटेड थ्रू एंगल थीटा फ्रॉम स्टेबल इक्विलिब्रियम पोजीशन from stable equilibrium position तो फाइनल पोटेंशियल एनर्जी क्या होगा माइनस पी कॉस थीटा ओके माइनस पी कॉस थीटा but for that now from stable to theta you have to apply the external torque so external work has to be done okay so write down वर्क डन एक्सटर्नल वर्क डन शॉर्ट में लिखो एक्सटर्नल वर्क डन क्या होगा एक्सटर्नल वर्क डन W is equal to change in the potential energy so that will be UF minus UI तो फाइनल पोटेंशियल एनर्जी कितना है माइनस पी कॉस थीटा माइनस ऑफ UI कितना है माइनस पी ये माइनस माइनस क्या हो जाएगा प्लस पी माइनस पी कॉस थीटा सो वर्क डन इज इक्वल टू पी इनटू क्या आ जाएगा 1 माइनस कॉस थीटा दिस इज व्हाट वर्क डन टू रोटेट डायपोल फ्रॉम 0 डिग्री मतलब स्टेबल इक्विलिब्रियम टू थीटा बट ये सब ऐसे हम उल्टा खा रहे हैं मतलब फर्स्ट पोटेंशियल एनर्जी डिफाइन किया ओके वी डिफाइंड द पोटेंशियल एनर्जी एंड कैलकुलेटेड वर्क एज चेंज इन द पोटेंशियल एनर्जी बट वैसे भी तो वी कुड हैव यूज्ड दैट वर्क वाला फार्मूला क्या माइनस पी इनटू व्हाट cos थीटा टू माइनस cos थीटा ये वर्क वाला फार्मूला था ही ना ओके सो माइनस पी फाइनल एंगल कितना है थीटा एंड कहां से रोटेट किया फ्रॉम वेयर यू स्टार्टेड 0 ये तो हमने किया है सो माइनस पी इनटू cos थीटा माइनस 1 सो यू कुड हैव डन दिस फ्रॉम माइनस यहां पे डाल दो p इनटू 1 माइनस cos थीटा तो पहले भी किया था so this is the work done to rotate the dipole from 0 to theta but here we have done by change in potential energy formula and here directly from work formula so remember potential energy is defined with respect to 90 position to theta position minus p cos theta this is not the potential energy remember not the potential energy okay and note work done in rotating the dipole from stable equilibrium थ्रू 90 डिग्रीज, स्टेबल इक्विलिब्रियम टू 90 डिग्रीज। ठीक है, यही यूज करो फॉर्मूला, स्टेबल इक्विलिब्रियम टू 90। स्टेबल, ये स्टेबल का ही है, तो 90 कितना होगा रे? 0, cos 90 0, तो वर्क डन विल बी व्हाट? P, वर्क डन इज इक्वल टू P। एंड फ्रॉम स्टेबल टू अनस्टेबल अगर मैंने रोटेट किया, स्टेबल टू मतलब 0 टू 180, नोट दिया गया 0 टू 180, तो cos 180 -1 होगा, 1 minus -1, so work done will be 2p, time pass करेंगे। So work done to rotate from stable to 90 degree and stable to 180, that is unstable position. And specifically I have taken this question over here because it creates a confusion in the minds of students. An electric dipole of moment P is placed in the position of stable equilibrium. Initially of stable equilibrium in uniform electric field of intensity E. Okay, stable equilibrium में placed है, stable, and is rotated through angle theta. Is rotated through angle theta from the initial position. The potential energy of dipole in the final position. Potential energy will be minus P cos theta. Minus P cos theta. Whether you rotate from stable to theta, it is minus P cos theta because potential energy is defined from 90 to theta position. So it is whatever. तुम कहाँ से भी रोटेट करो, अनस्टेबल से थीटा पे रोटेट करो या जीरो से थीटा पे रोटेट करो, पोटेंशियल एनर्जी विल बी माइनस पी कॉस थीटा। ओके, बट इफ यू आर आस्क्ड वर्क डन टू रोटेट फ्रॉम स्टेबल टू थीटा, वर्क डन इज गिवन p into 1 minus cos theta. So work done is this, and potential energy is minus p cos theta. So there should not be any confusion in work done and potential energy. I hope this is clear. कोई क्वेश्चन चाहिए तो तुम लिख के ले सकते हो। Okay, keep the screen open because I am closing the lecture. So closing this thing, so you can write down this and take the question. Okay, you can write there for potential energy option A है minus P cos theta, and for work done W, वर्क डन W अगर पूछा जाए तो ऑप्शन बी है P into 1 minus cos theta. Okay, you can write the question and you can write these two answers. I hope this is clear.